In this video, let's talk about the Houdini Digital Asset Python module, which is a way for us to create a specific Python code for specific HDA and then store it actually inside the actual HDA file. So let's get into it. Let's pick up some of the more general also information about the structure of HDAs and some of the cool stuff where we can find everything we need and how can we also reference this Python code. So let's get started. Let's start by creating a digital asset. So I am going to just create a digital asset. It's going to be just an empty asset because we don't really need to for this asset to do anything. We just need for it to be a digital asset so we can take a look at its structure. So I'm going to just call it an empty asset, and I'm gonna put it in my HDA path. Let's accept it, apply it, and that's it. This is my empty asset. And now let's go to the type properties and let's go to the scripts, and actually let's add our Python module like that. Let's leave it at empty. I actually locked it, so accept. Now we can actually start by editing extra sections source code. You can see now that we added our Python module for our assets, you can see now we can actually go ahead and start editing some of these Python code. So we could edit inside here, but this editor is not that great actually. But this is great that you can actually in Houdini, I think with the labs node, with labs installed, you can actually start editing with your external editor. So let's go ahead and open it up. Now that we have opened up our Python module inside external editor, what I did is actually added I added two string parameters and two float parameters for our HDA, so we can reference this Python module inside these parameters. So let's go ahead and actually paste some data inside our Python module. So I'm going to create two functions, and both of them, one of them is going to return a string, and another one is going to return an integer. So, and now that we have pasted inside, you can see it's actually going to update this code inside our Python module. So go ahead inside the scripts. You can see it's have updated. I didn't have to press any update button. It basically automatically refreshed, and our code is already inside our Python module. Now let's create some references for these functions. So first of all, let's go to the help and talk about two functions in particular. So it will be hou.HDAWD and PHM. So you can see these are basically a shortcut functions for us to reference the current node and the current hou.HDA module. So you can see that for the hou.PWD, it's basically same as the hou.node and then just a reference to itself. So let's just write it in, and if you're writing inside the node's parameters, you actually don't have to use who, you can just write in PWD. So let's go to the expression and edit expressions, and let's write in. Let's apply it. So let's change it to which is a toggle expression. I have a hotkey for it. You can see it's basically a reference to this node. So this is very nice, and actually now that we have, you can see, and also you can see that this is going to actually give us the hou.node object. And of course, once you have a hou.node object, you should actually go to the help and take a look at the hou.node class, which is basically this has returned this class, and we can actually go ahead and actually reference the HDA module. Just go to the module to go to the search for it, and you can see there's a couple of shortcuts for us to also reference HDA module, which is the HDA module, and there's also a shortcut for it. So you can see that basically these are the same thing. They're going to return the hou.HDA module. It's basically just a shortcut for it, so that you don't have to write it so long. But you can see that you can do either one of these. So let's just copy this one, paste inside, apply it. You can see we have a reference to it. Let's leave it like that. Let's actually go to the next one, and let's edit the next one. So I'm going to copy this, paste inside, and let's use the shortcut for HM, like that. So you can see we have basically the same references for both of them, but for us to, so basically these are totally valid ways for us to reference our Python module, which is filed inside here. But you can see that there's one very quick way for us to actually get our Python module reference inside our parameters, and this is it's actually suggestive inside here. It's hou.PHM. You can see hou.PHM. We don't even have to write. We don't even need to reference our node for this one. So we can just go ahead and add the expression and just write inside PHM, and that's it. Applied. Close it. You can see now we are referencing HDA module, the same as this one. You can see how much faster was it. And now let's just reference some of these functions. Let's for the number and for the my text, which I'm going to use the same as the long method. It doesn't really matter, like that. You can see now we have returned these values that these functions return. And remember, these functions have to actually return something. And now that we know a little bit more about the basics of the Python module, let's go back to the type properties. Let's take a look at the concept of the global kwargs dictionary. So let's go to the help, and I have opened up the, so where is it? This is the Python script location, and you can see that, so this talks about the handler scripts. You can see that these handler scripts actually run in the environment with the global kwargs dictionary. And you can see for every one of these, so we do not only have a Python module, we actually have a bunch of event handlers that's going to trigger whenever whenever these things happen to the digital asset. So let's say is updated. Let's go to the on updated. So this is basically what runs when we press apply. Basically when we change something or don't change anything, just press apply. And now since all of these callbacks run in a global kwargs dictionary, we can actually go ahead and take a look what kind of keys is actually going to give our onUpdated. So let's just print out. Let's print out kwargs. Let's apply it. You can see I press apply. So basically this script got triggered because we updated our HDA. Let's take a look at it. So you can see we get our type key, which basically the reference to the node type, and we get our node reference to our node that we run this script from. So this is very handy. Now let's actually go to the Python module and also let's take a look at what we actually can get out of the kwargs. So to get our kwargs, let's actually return them in our script up here. So let's actually on a full text, let's just delete it and return. Let's return kwargs inside here. Let's apply it. Let's take a look at it. You can see on Python module, you can see we have only one key, which is type, which returns the type of this node. So you get only one key. You can see in here we got two keys. So it does vary, and in here you can see all about what keys are actually going to be returned when we use any of these callbacks. And now let's say on updated, we wanted to run some script from our Python module. Well, with the kwargs dictionary, it's easy. All we really have to do is reference our kwargs. Remember, it gives us a node reference. Let's reference our node key, and then from the node key, remember, we can go to since it gives us a node class, we can go ahead and press HM, the quick way for us to HDA module.hm, and then just let's run some script from it. Let's return full number. And that's it. Let's apply it. And let's actually print it out, since it doesn't really have anywhere to show it. Let's just print it out. You can see we now basically got the got the function from the Python module, update it, and we run it. And it is always a good idea to just go ahead and from any of these keys that it kwargs actually returns, just go ahead and copy the object it actually returns. So this time it actually returns the object, but other times the kwargs can actually return just a string or whatever. But this time we know it's a hou.HDASection type. Just go ahead and go to the help and paste inside. You can see this is a class. It has two unique methods of its own, and you can see that most of other and all of the rest of them are the methods of the super class, which is the node subclass. So you can see that we can get all of these things, and you can see what it actually returns. So you can basically jump around the different classes, and basically it's all about what kind of object you can get from any of these kwargs or whatever, and how can you get to the class and to the object that you actually need. So just have to jump around and take a look at what you actually can get. So you can see you can actually get the HDA definition, you can actually get the HDA module reference and all of that. You can actually get also the node reference. So go ahead and press in node. You can see there's instances, so it's going to return the tuple of all the nodes of this type in the current scene. So let's try it out. So let's just go inside here and let's actually do it like that. So now we have a reference to this HDA module, and we know that in the HDA module there's a kwarg dictionary .kwargs like that, and we know it's called a type. And now we have a sub.node type object, and now we want to get the instances. So dot instances like that. As you can see, now we have basically got to from our current node reference this HDA module, got its kwarg dictionary key type, got our sub.node type class, and called the method of instances, which returns all of the references to returns the tuple for all the nodes of this type in the current scene. You see, and if we duplicate it, you can see this actually goes and creates two of these. And now let's quickly just do some of the classes that we can get from our digital assets and what kind of overview of what they do and something like that. So just go ahead and help and press on HDA. You can see there's a bunch of different classes. So I want to look at HDASections, options, and HDADefinition. So you can see there's a class and there's also a function for it. So let's take a look at those. And since our HDA global Python module always returns a kwarg type object, which is basically the node type class, which is a great way for us to enter to some of these HDA classes on their own. We can always basically get access to this class and then get access to all of these HDA classes. So let's do that. So we can get the same object also by just dragging this inside here. So basically now we have a node reference and we can just type in type, and this is basically the same object reference as inside here. So but obviously this is just for the demonstration, but there are many ways we can get the object for these nodes or any other node. You will see that this node type class description says information common to all instances of a type of node, such as parameters. You can see there's a bunch of stuff we can do. Basically this is a node type, but this is the sub node. So since we are at the sub context, you can see it's actually automatically gave a sub node type. And you go to the sub node type, the methods are basically the same, almost all of them, only with the two different, basically a unique methods to the sub node type, but all the rest of them are actually just a hou.node type objects. So and you can see that not all of them actually have, since we have many other types of nodes inside Houdini, not all of them have their own unique type. So only the 3 of them has their own unique methods, but all of the rest of them are basically the common things that for the node that we actually can get. And some of these are just a name, which is basically a unique name for every node. So this is not the label that we write inside here. This is actual name of the assets inside here. So let's quickly get our asset name. So type, now that we are inside type, node type class, write in name, and this is great. Actually, I changed the name of it, so since it's reference to the old name, we have to two W's like that. So this is why we want to work with the Quark dictionary inside our digital asset, because once we update it, all of this is going to be updated. But since I just want to demonstrate, it doesn't really matter. So you can see now we got the actual name of the asset, which is right here. And this is great because also time is actually different functions actually asks for the actual name of the node. But what I am most interested in is actually get the hou.HDADefinition. So let's take a look at how can we get it from our type. It should be just a word definition. So let's go ahead and get our definition for this node. So you can see it now returns the hou.HDADefinition, which is right here, class. And you can take a look at it. Basically says where it is located, which is basically within this HDA. So this is the definition is within HDA. Basically this is what basically defines our HDA. So you can read all about this, what it does. You can see there's a bunch of stuff we can actually get. You can see we can get back our node type. So from node type we actually got our definition, but what I could do is just write node type. You can see we're basically gone one step backwards and got back our node type. If we need, go back and get some of these if we start from our definition. This is one way we can get our HDA definition. Another way is actually getting a function. We can actually define all of the things that we need, all of the things that actually gets the HDA definition, and we can just call it from a function. You can see in function we need the 3 arguments, which is top node type, its name, and its location. So let's go ahead and try this one. So first of all, let's write it inside here. So since this is a function, we do not need any starting point for this, since it's just a function. Let's start at hou.HDA definition, and let's start writing some of these. So we know it's a sub node category, but if you need other categories for our, if you need any other categories, you can just go ahead and set here, and you can just copy this kind of a common thing that would be for all of them, paste inside here. You can see it's gonna basically return all of the type categories, which also should be also functions, which basically just object. So let's since we know it's a sub node category, let's paste inside. So next up we need a name. So name, it would be empty asset. Obviously this is where you could get, obviously not manually write in, we can get the name of it by referencing the node, but this is just for the demonstration. And then we need to get the location of the asset. So obviously you would probably want to use the global variables from Houdini, but I'm just going to copy my absolute path and just put it inside here, and that's it. I'm gonna press enter. So you can see it actually returns the definition, basically the same definition as from our node, from our type class definition. You can see they're basically the same definition. In this HDA definition class, there's a bunch of good stuff we can get, something like type information, the overall information of metadata, something like a version of the HDA, the comment, which is actually right here, comment. So this is not this big comment, which actually can actually show inside network editor. It is just a comment inside here, which is, I guess, not used by anything, but we can still set it if we want to in an actual HDA setup, some comment about it. The icon, all of this is user information, turns a string containing user specific information about the asset definition. But I am most interested is actually about the embedded files, which is the sections of the HDA. And you can see there's also the inputs and outputs, the minimal inputs, that's the minimum number of connected inputs that node instance of the digital assets can have. So they should be actually 0, I guess. Let's try it out, because we actually do not have a, well, it's going to be these numbers. So the minimum inputs is going to be 0. So let's try it out. Yeah, it's 0. Useful information and also parameters, which probably could use another video about the parm template group. How can you basically copy parm template and create the, basically copy one parm template to the another asset. So that could maybe be a pretty fun video. So that's that. But what I'm most interested in is actually in some of these other classes, something like HDASection and the HDAOptions class. Now let's call our HDASection class. So from definition, all we have to do is write sections, and it's going to be a long text. So let's actually from pprint import pprint, and now actually let's use the pretty print, and basically let's call it the same line of text, line of code, and just a pprint in front of it, so we get every dictionary entry in a new line. So let's do it again, something like this, and you will notice that lots of these are basically generated automatically by HDA, by Houdini, but some of these names you will notice that, so there's a PythonModule, there's a type properties options, there's a bunch of the viewer state module, which is basically the viewer state inside here for our interactivity in a viewport. So all of these are basically different sections of the HDA we can actually access also from here. So let's actually go to the help, and from the sections you can actually read the information of it with the contents method. So let's actually access our Python module. So let's use it like that, section, and since it's a dictionary, let's get a Python module key. So now we get only that one specific key from Python module, and now we have HDASection object, and let's read the content of it. You can see we have basically gotten our Python module. Obviously it's not the most easiest to read, but you can see there's the /n, basically there's an enter, and you can basically read the contents of our Python modules. And for the demonstration's sake, let's actually print out all the contents of every section of our HDA. With this basic loop, let's apply it, and let's take a look at every key and its value of our HDA contents. So let's go to the very top of it. You can see the value or comment is also one of the sections of our HDA, which is our own written inside comment inside here. This time I just wrote this, but we can write in whatever we want in it. There's some automatically generated code for it. There's a create script, which is basically going to say that it's automatically generated script. There's a default state, which is the viewer state default, which is basically what state that is going to enter when we press enter. It gets information from here. Let's take a look at the dialog script, which is basically all of our parameters and the labels of it and the strings. So you can see that we have for our HDA we have 4 parameters, which is a new parameter 1, 2, 3, and 4. You can see there's all of these are actually referenced inside here. So new parameter 1, 2, 3. There's, you can see there's a label, which is name we didn't change, it's just a label. The type of it, range. So some of these basically basic information about every one of these, the range of it and all of that is also stored inside here in dialog script. So let's take a look at what else. Some more extra files from the, so what is this? Extra file options. Oh, that's, I guess it would be exercise inside here. So that may be something for the other videos. Internal file options on updated. These are all of our startup script on all the event handlers. You can see we have two. There's a Python module and there's on updated. There's a tool shelf, which is this contains the definition of shelves, toolbars, and tools. Type properties option, and in some of these options you can see there's make default and something like maybe unlock on create, which you can find in a save option in our type properties in our HDA. There's a unlock on save, unlock new nodes on creation. So this is unchecked, so that's why it's 0. But if we check it, apply it, and let's just run this loop again, we're going to find out that you see unlock on create is actually now 1. So this is actually updated to the 1. So type properties, let's take a look at it. Viewer state install, which basically every time we update our viewer state, it's going to basically uninstall and install it again so that it updates and our view. So basically there's a install and uninstall. So these maybe we're going to talk about in the next video, and I'm going to talk about the viewer state module, about the menus and all that. But if you take a look at our viewer state module, this is basically the same code that is inside our interactive viewer state we created just to see the kwargs type name. So, and now for the last class, let's take a look at HDA options class, which is a little bit different than other classes, which is basically, this class is not specific to any specific HDA. You can see that it's basically just a data structure that we can basically call, edit it, and then just assign it to the digital asset. So let's take a look at it. On a help page, you will notice that we are basically, from our previous call where we print out all of the sections contents, you can see basically done the same in a help. Basically we call definition, and in sections we have basically type properties options, which is exactly this one. And you see that there's a bunch of values that are current nodes type properties set 1s and 0s. So let's actually go ahead and edit these. So first of all, let's create an instance. Let's go to the Python source, because we need a couple of variables here. So first of all, get our definition of our node so that we can then call it and set the section. And now let's get the section. So you see that definition, then it prints out. So we don't need to print it out because we already have this printed out. And then let's get the options variable. And options is going to be basically definition.options. Just paste it inside, and this is basically all of these functions underneath right here. Let's actually edit some of these. So, and now what we can do is call any of these methods underneath. So you can see in here we have, it's called save spare parameters. If we paste, you can see return the save spare parameter option. So, but what I want to do is maybe let's look up something else. So let's edit something. So options start, you can see all of them are going to be actually referenced already. So I want to do is actually forbid outside parms. So let's take a look at it. So outside parameter is basically option inside digital asset that's going to not allow us to reference any of the nodes that are outside the subnetwork, basically outside of the, we cannot link any parameters outside of the network inside our digital asset. So if I put down a box and let's say I want to reference my size of this box, I drag it in, you can see it's going to complain. So this option is right here under the gear, forbid linking parameters from the outside this subnet. So if I unlink it, now I can copy it and paste inside. So actually I'm going to forbid, let's not allow it, and let's call it to see the option. So you will notice that there's a bunch of this, there's a forbid outside parm, there's a boolean, it's going to return the current value, and we can set it. So let's actually get the current option. So options dot for bit outside parms. Let's see the current option. So let's go to the end of it and let's apply it. I guess we should print it. So now it's true, and now so we know this is true. And let's go to our type properties. Let's take there should be this also inside here. For bit outside parms, this is 1, which is true. So this is true. So now let's set it to the false. Let's delete this print. Options.set set for bit parms, and basically just a boolean inside it. Let's put it to the 0. So basically no. Let's apply it. So now we have changed these options call, and now all we have to do is, so basically we call these options and we are now inside this class. Now we can call any of these methods, modify it, and all we have to do is now is actually set it to this HDA. This is very easy. It's basically called the definition of our HDA. So that's why we created a variable and set options dot set options, and inside we just have to reference our variable that we did our modifications on, which is the options, just like in here. Applied, and that should be it. Let's take a look at it. Actually, let's take a look at our digit class. It should be now unchecked. You can see for bit linking is being unchecked. So we know that this is actually working. So now let's put it back in. Let's put it 1. Let's apply it. Let's take a look at it. And now it's back on. That's it for this tutorial. I hope you found something useful in it. As always, when I think I'm gonna make shorter videos, I always go in half an hour long. So yeah. So okay, see you next time and take care.